Hello all. This is Dr. Jenifa from Department of Artificial Intelligence, Madanapalli Institute of Technology and Sciences. Today we are going to see, in this video, we are going to see the topic automating daily life with IoT and AI and ML perception. Okay, so we have seen in recent days like without IoT, without technology, we cannot survive, right? So, the flow of my presentation is as follows. We are going to see some introduction about IoT and AI, and then how this IoT influences the morning automation and the algorithms involved in this morning automation, daytime enhancements, algorithm involves, and then the basic key technologies and the frameworks, challenges, and the future directions at last the conclusion. Now, when the term comes as technology, there's nothing without technology, isn't it? From the smartphone, can you imagine you can live without a smartphone? No, right? From the morning when we are waking up from the bed till night when we are going to bed, we are using mobile phones like anything for messaging, calling, communicating through mails, or simply playing games, watching videos, okay, whatever it is. So, technology plays such a vital role in our day to day life. So, this presentation is trying to explore a few algorithms that makes this transformation possible, okay, through especially through the IoT. Now, first thing is the morning automation. So we all know that without alarm clock, 90% of us nowadays cannot wake up. Okay, it is not like the earlier days. So obviously we need some smart alarms, and then the environmental control. Okay, such as how to lighten up. Okay, how to control the devices. Okay, how to save the energy, and then coffee making. Obviously, the basic thing nowadays getting automated. Daily agenda reminders. In this world of technology era, we always used to forget to write something in our notes and keep on turning them to get the data. Instead, we always depend on our mobiles, our smart devices, right? So these are some of the, I'm not concluding or I'm not telling all the automation, morning automation techniques, only a few of them, and these four are some of them. Now, when it comes with the smart alarms, why do I need it? Okay, so when in the world of moving fast, right, I need to take enough sleep. But as a human being, I'm always overthinking, right? So whether I'm keeping track of my sleep properly, no, obviously no. So we need to track our sleep, and then to track that, I need to identify my sleeping pattern. Okay, so why should I track this pattern? Sorry. So why should I track this sleeping pattern? So this allows to analyze my sleep. My system, my AA model is trying to analyze my sleep, and it can tell you some suggestion, okay, how far you are sleeping, whether it should be improved or not. Okay, so that kind of thing can be done, and that is the main advantage of this smart alarms. Okay, so now when it comes with the algorithms involved, what are the algorithms that can be used for smart alarms? Again, we are not going to discuss everything, a few. Okay, so first thing is support vector machines, random forest, recurrent neural networks, convolutional neural networks, gradient boosting machines, hybrid models, clustering algorithms. And among these set of algorithms, we are going to discuss only about SVM. Okay, so in this. So, how actually, when it comes with your IoT and AI, generally how they are actually communicating? We all know that IoT, it involves a collection of sensors, right? So those sensors are collecting data, okay, through. But here in smart alarms, we are using some set of smart devices, sensors, okay. So whereas these IoT devices using sensors, they are collecting the data, and then the AI, artificial intelligence, uses those data to manage them, to predict something, right? So this is how our IoT and AI actually correlates. They are trying to communicate. Now, when it comes with your smart alarms, okay, the relevant features what we are here, we can see here are the sensors we can see here are accelerometers, heart rate monitors, or EEG devices, where using these EEG devices, we can even find the electrical signals of our brain, which is very important for tracking the sleeping. Okay, when I am collecting the data using these set of sensors, what are the parameters or features that I can collect? The movement patterns, okay, the movement of humans during sleeping. Okay, then heart rate variability, how your heart rate is varying from deep sleep to mild sleep, etc. And any other spectral features from your EEG signals. Okay, so how we can accommodate everything? Yeah, nowadays everything comes with the wearable devices, right? So your sensors can sense everything. Now, when it comes with your SBM, okay, so as like all the other ML algorithms, it is going to label your data, and then it is going to contain some set of sleep stages, where here I have given some examples like wake, light sleep, deep sleep, rapid eye movement, where most of us in this right now, the current scenario of this moving, fast moving world, we have that REM sleep, right? Rapid eye movement sleep. So, which we used not to recognize during our sleepy time, but our sensors can do that. Okay. So, based on that, it is trying to extract some features, and those features can be given to train the data. Okay. And this can be used by SPM to identify our sleep stages. Okay, so to classify the sleep stage, as we have seen in the previous slide, there are different types of sleeping patterns, right? So once I have identified that, okay, so I am trying to classify the stages of those sleep from the real data, what we have collected through the sensors, and they are all stored already, right? Then it is trying to classify what kind of sleep currently I am having by using the extracted features from the previous stage. Okay, and then maybe I'm setting an alarm from 10 to 6 a.m., but I'm not actually sleeping between the time of 10 to 12. Okay, it may be a mild sleep or a REM type of sleep. So, my alarm can be, I can get a suggestion from my AI model that what kind of alarm setting can be done. Okay, it is giving a suggestion for us because I don't know how much sleep I got peacefully. So, my AI model, along with the help of sensors, it can help us. Based on this stage, sleep stage classification, now I can go for the personalized alarm scheduling. Okay, so based on all the sleep stage identifications from the data collected from me, from the individual being, okay, it is trying to learn the individual sleeping pattern. My model tries to learn it. Once it learned, it is trying to identify the optimal time to wake up for you. As I told, if I'm setting the time as 10 to 6, but I'm not sleeping from 10 to 12 or 4 to 6. So now my smart alarm can set the time for you when you are supposed to wake up, so that your sleeping window is perfect. Okay, so maybe if you are sleeping, if you are not able to get more sleep during the in between times, okay, so it can intimate you, okay, what kind of adaptation you are supposed to do, and hence it tries to improve the sleeping time or the quality sleeping time of you, of an individual person. Okay, now when it comes with the environmental control, okay, again, the algorithms involved in environmental control are linear regression, decision trees, random forest, gradient boosting machines, neural networks, reinforcement learning, clustering algorithm, support vector machines. Okay, so among that, now we are going to see how the linear regression models can be used for environmental control. Okay, so the first thing we are supposed to do is actually data collection. Okay, so the data collection that can be done by the IoT devices, that is by using the sensors. Okay, I'm trying to collect the um, data. Okay, and then we are trying to pre-process the data. We all know the purpose of doing the pre-processing or cleaning our data is to ensure the quality of our data. So when we are doing this pre-processing, it will eliminate the missing values. Okay, if there is any outliers, it can be removed so that the end data can be scaled to a similar tone. Okay, and maybe if there is any data to be changed, not changed, if there is any data augmentation is required. So that can also be done during your data pre-processing. Okay. So next comes our feature selection. Okay. So to select our feature, as I told, my AI model, okay, now here I'm mentioning it as linear regression model. It is trying to collect data from some of the IoT devices, right? So what are the features it is trying to collect? Okay, so the first thing is outdoor temperature, because I'm trying to control my room environment or my office environment. Okay, so outdoor temperature, humidity, the sunlight intensity outside and its influence inside my room or cabin. Okay, occupancy patterns and the time of day. Okay, which is very mandatory when we are collecting the patterns. Okay, when we are collecting the features through IoT devices, sensors, not just for our environmental control or any of our day-to-day life routines. In all the cases, it is required, right? So now once the data was collected, okay, and then pre-processed, now we are going for modeling. Okay, so once we are doing that modeling, okay, that means how we are identifying the relationship between our selected features and the target variables. Okay, for example, how the AC consumes, the AC in my room consumes the energy, okay, or the lights in my room consumes the energy, okay. Based on that, we are going for the data splitting for my training and testing. Okay, so majority of the data we'll be using for training, okay, as it is a linear regression model. Okay, then we are supposed to evaluate the model to identify the performance. Okay, now once it is done, the next thing to be done is our prediction. Okay, so once my model is trained and evaluated, now I can go for predicting our model. Okay, so how I can based on what I'm going to observe my environment is, for example, here I have given the humidity or current outdoor temperature. Okay, whereas it depends on the device or the place where we are about to apply this kind of environmental control. Okay, so based on this, we are going to observe the environmental factors, and based on these factors only, my model is going to predict the energy consumption. For example, here AC, where it can be of light or a fan or anything else. Okay, so when we are coming for the model evaluation, okay, so why, how I can model evaluate? We all know why we are evaluating the model, to identify the accuracy of or the performance of my model, right? So now once I'm doing that, how I'm going to evaluate it, based on what parameters? Okay, so first thing is your mean square error, root mean square error, okay, and coefficient of determination, that is R square error. So based on these values, we can evaluate our models. So once I have evaluated, now I have to optimize it, right? So now I have to control my environment. Okay, so using those strategy, what I have observed till the previous slide, I am trying to optimize and control my environment. Okay, so if it is okay, whatever the control that I have done so far is perfect, then it is okay. Otherwise, what should I do? I have to iterate the perform testing and training process. So next comes our daytime enhancements. Okay, so till now we have seen the morning routines. Okay, we have skipped the daily routine observer and the coffee maker, automatic coffee maker. Now we are moving directly to the daytime enhancements. Okay, so in the daytime enhancements, we are mainly concentrating on the energy conservation, okay, then home security, commute optimization, automated cleaning, and here we can see what are the algorithms that we are using for this daytime enhancements. Okay, energy conservation through AI driven sensor data analysis. Okay, so how much energy you are consuming per day, per hour in our room or in a cabin, in an office. Okay, and then home security, where we can use CNNs for surveillance and anomaly detection, where we all know CCTV camera. If a new person comes, not just using the CCTV camera and then training them, okay, instead we have some ad hoc devices, like once a new person, some unknown person comes, okay, your device can identify that immediately, right? Then commute optimization, okay, the communicating. Then this can be done using your deep Q networks, DQN, especially in autonomous vehicle navigation. For automated cleaning, okay, there are so many devices nowadays available. So it can be done using genetic algorithm, and and this genetic algorithms can be used to identify the efficient cleaning paths. When it comes with your optimized control system, that is mainly for energy conservation, okay, our AI algorithms generally try to analyze the data, whatever the data it is collecting from sensors, it is trying to analyze that. Okay. So based on that analyzation, it is trying to optimize it. Okay. Mainly for the HVAC systems. That means heating, ventilation, and air conditioning systems. Okay. So why should I do all these things? Why should I optimize that? So that if I am getting that kind of data, I can give some my model, okay, my AI model can give some feedback, some suggestion to the user that how much energy the user is consuming, the pattern in which, for example, the AC is consuming more energy or your heating system is consuming more energy at what time. Okay, all these data can be suggested, predicted by our AI model. Okay, so what are the ML algorithms again can be used for our energy conservation, reinforcement learning, model predictive control, support vector machines, genetic algorithms, fuzzy logic control. Okay, so these are some of the algorithms that can be used. Whereas now we are moving for evening adjustments. That means how once we have seen how morning the IoT with AI can work in our life, and then for the other daytime control. Now when it comes for the evening adjustments, okay, so now it is time to rest at home, right? So how I'm going to manage my temperature at room? Okay, then for which I can use the LSTM predictive model. Okay, and then vehicle charging. If you are nowadays, e-vehicles are most popular. Okay, how vehicle can be charged, what are the optimization algorithms can be used for my vehicle charging so that it can be optimized. Okay, then dinner planning. Okay, now the meal suggestion based on your diet, okay, based on your plan, okay, that can be done using your IoT and your AI models. Okay, and then of course the entertainment selection, now without which we are not, right? If you are using Netflix, Amazon Prime, YouTube, whatever it is, based on your mood, once you select a song, a video, a drama, whatever it is, you are keep on getting the choices, right? So that can also be done. So this is how actually the technology, especially IoT with AI, plays a various role in our day-to-day life. Okay, now the main key technologies, okay, involved are the frameworks with respect to programming. It involves in our day-to-day life of this IoT automation, or here I have listed a few again. Okay, so TensorFlow, PyTorch, AWS IoT Core, Google Cloud, so that the data can be stored. Okay, right. So whatever the data that is collected by IoT sensor, that can be stored there. Okay, then Philips Q, Nest thermostat. Okay, then Tesla Autopilot, Waymo. Okay, for autonomous driving technologies. These are few. Whereas it will keep on change. Again, technologies keep on change. It will be changed in future too. Okay, so now the combination of this IoT, okay, the conjunction of this IoT with AI and ML, it holds really such a great potential for our day-to-day life, so that our life becomes more efficient, okay, and secure and personalized. But here comes one question for us, okay, when it comes with the conclusion, when the conclusion of security, okay, so I can say my thing is, yes, it is efficient, it is personalized for me, but whether it is secure. So here we have the challenge, right? So what are the challenges we are facing? The main thing is security, how much ethical it is when I'm sharing my personal data with the IoT cloud, the cloud platform. Okay, so the security is a major concern for which as a technologist we have to be very responsible. Okay, so how ethically we can handle the data, the personalized data of an individual person. Okay, that also plays an important role, and that is one of the main challenges we are facing when it comes with combination when it comes with combining the technology of IoT with AI to do our day-to-day life. Okay, even our doors, okay, nowadays comes with automatic keys. Okay, how we are going to manage them? Okay, how we are going to save that passwords? Okay, everything is a major concern. Okay, but still, amongst all those drawbacks or the challenges what we are facing right now, um, IoT along with the AI now provides such a smart and efficient lifestyle for we all people. Okay, so thank you all. Thank you for listening this video. Let us meet in some other video with some other new topic. Thank you.